This video presents the tag genome dataset for books. Tags are keywords that concisely describe items such as books or movies. Most tags are binary, they either apply to an item or not. For example, the movie Back to the Future could be tagged with time travel, drama, and futuristic. However, tags can also include continuous relevance scores indicating the degree to which a tag applies to an item. For example, although Back to the Future is mostly about time travel, it also contains elements of drama. Therefore, the tag drama could be applied with a relevance score of 0.5 on a scale from 0 doesn't apply to 1 applies very strongly. Tag genome is a data structure which uses these continuous relevance scores to encode items. In tag genome, an item is represented as a vector, where each value corresponds to the degree to which a tag applies to this item. The authors of tag genome applied this data structure to the movie domain, generated the dataset, and made it publicly available. This dataset has received considerable attention in recommender systems research and has been used in a wide variety of studies, from calculating similarity between movies to generating descriptions of movies that appeal to certain user groups. In this paper, we introduced the tag genome dataset for books. The key feature of our dataset is that it has a considerable number of tags that overlap with those from tag genome for movies. This enables us to solve a number of cross-domain problems. Here are two examples that are based on the actual data from the two datasets. The combination of genomes for movies and books allows us to build cross-domain recommender systems, where we recommend books to users based on their preferences in movies. If we know that the target user liked movies on time travel such as Back to the Future, Groundhog Day, and The Butterfly Effect, we can sum up vectors of these movies and recommend the book, which is the most similar to the resulting vector. In this case, this book is Sapphire Blue, which is also about time travel. The combination of the two datasets allows us to describe books with movies. By comparing movie and book vectors, we can generate the following description. The movie Jumanji has more lions and jungle, but less England and mystery than the book Harry Potter and the Chamber of Secrets. However, both have a lot of fantasy, action, adventure, and children. We generated tag genome for books based on the Goodreads dataset. We used tag applications, ratings, and reviews. To compute relevance scores, we used the same procedure as the authors of tag genome for movies. First, we selected tags and books from the Goodreads dataset. We then extracted features from raw data related to these tags and books. These features included variables such as whether the tag has been applied to the book, average book rating, and the number of times the tag appeared in the review. To train prediction models and generate the scores, we conducted a survey in Amazon Mechanical Turk, where we asked users to indicate a degree to which a tag applies to a book on a 5-point Likert scale. Finally, we predicted book tag relevance scores with the state-of-the-art item tag relevance prediction methods. We generated book tag scores for around 10,000 books and 700 tags, based on around 50 million tag applications, 5 million reviews, 5 million user ratings, and 150,000 book tag ratings. Around 500 tags from our dataset correspond to at least one tag in the movie dataset. For both datasets, the error of item tag score prediction is around 0.8, which is less than 1 point on the 5-point Likert scale from our survey. We later scaled these values between 0 and 1 for the final dataset. Tag genome for books is available on the Groupland's website via the following link. We also shared raw data, tag genome for movies, and the pipeline for its generation under 2 other publications. In case you are interested in generating your own tag genome for the same or different domains, feel free to check the GitHub repository. We would like to thank Mensing Wang for allowing us to publish this dataset and organizations that supported this research, the LibDat project and the Finnish Center for Artificial Intelligence. Thank you for your attention.